Hello friends, today we will start our exercise 7.9 where we will do the definition. But before that we understand the concept first. What is definite integration and what does it mean? Okay, uh, let's understand. Definite integration of a function fx a to x. The area under curve would be ax. I mean, if there is a function fx, let's say this is a function fx. So the area under curve from A to any point from A, x equal to A, to any point, it could be x, any value. But the only condition is that the function should be continuous from A to x. The function should be continuous from A to x. It should not break at any instance between A to x. Then this definition does not hold, right? So area under curve from A to x for the function fx, the total area would be ax. So that is the area, and that is how definite integration is defined. Okay. So this is what first theorem, fundamental theorem of integral calculus says, that area under curve is actually the integration of the function from A to B, right? That is the first fundamental theorem. Okay. Second fundamental theorem says that if there be a function fx whose integration is capital Fx, and if it is integrated from lower limit a to upper limit b, so it means after the integration of small fx we get the bigger fx, that is the integral value of small fx, right? After we do that, we'll put in the upper limit value, which is b in place of x. So we'll get the value fb, and then minus the lower limit value, which is a, will put into the fx, which is fa. So b is called upper limit and a is called lower limit, right? Okay, let's move on. This all is fine. Number 4 is important to understand. It says that for this to be defined, fx needs to be continuous in the interval a to b, closed interval a to b. Okay, why? Let's say there is a function x square root of x square minus 1. Then the definite integration of this function from minus 2 to 3 will not be defined. Why? Let's understand why. Actually, this function is not continuous from minus 2 to 3. Why it is not continuous, I will explain. Have a look here. The function is x and square root of x square minus 1. What is the domain of this function, guys? Domain of this function x square minus 1 is greater than equal to 0, right? And so x square is greater than equal to 1, and so x is greater than equal to 1 and is less than only when, have a look at question number 1, guys. Before we start integration, uh, uh, before we start do the definite integration, my first step is to integrate this function, right? The way we used to do before. So x plus 1 integration would be, x integration is x square over 2 plus 1 integration is, and after we have integrated, we will write the limits from minus 1 to 1. Okay, and then what do we do? In the integrated result, first we plug in the upper limit value. So 1 we will put in place of x all through the values. So we get 1 square over 2 plus 1. So we have done that. And then minus, then we'll put the lower limit value. So minus 1 whole square over 2 and minus 1. So first we put upper limit value and then we put minus lower limit value. So we get 1 over 2 plus 1 negative. This part is 1 over 2 minus 1. So we get 1 over 2 plus 1 minus 1 over 2 plus 1. So minus half plus half finish we get. So this is my answer, guys. It means that let me interpret the result. It means that the area under curve for this function y equal to x plus 1, the graph looks like this. The graph looks like this. The area under curve when x is minus 1 to 1, the area would be 2. Check it geometrically. Let's try. Let's try checking it geometrically. Do we have the area that? Okay. What is the base area? It is a triangle. So base length is 2. And what is the height of the triangle? When x value is 1, y value is 2. So the height is 2. So area of the triangle would be half base times height, which is 2 times 2, which is nothing but 2. So this is basically the same area what we have, right? And that verifies our first fundamental theorem, right? Have a look at question number 2. Question number 2 says 1 over x integration from 2 to 3. Guys, can we check how the 1 over x graph looks like this? X graph looks like this, right? So from 2 to 3, the function is defined, right? So we can get the answer because the function is defined. Okay, let's integrate now. So first of all, we will integrate 1 over x. 1 over x integration is log x, and we put the limits 2 to 3. Then we upper limit value minus lower limit value, right? If you have this, log 3 minus log 2 can actually be written as 2. Please remember, guys, in definite integration we don't give plus c, okay, right? And in definite integral we have the definite values, correct? Okay. That arbitrary constant in indefinite integral depends on the values of x and y, but here the x values are fixed, right? X values are from 2 to 3. That is why in definite integration we don't have c. I hope it is clear. Let's try question number 8 is integration of cosec x dx. Integration of cosec x is log cosec x minus cot x. So let me do the question here. Log cosec x minus cot x, and the limit is from pi over 6 to pi over 4, right? So let me write it. Pi over 6 is the lower limit and pi over 4 is the upper limit. So guys, please understand, first we'll put the upper limit. So let me do that. Log cosec pi over 4 minus log cosec pi over 6 minus cot pi over 6. Hope it is clear, guys. Okay. Then we'll solve it. Root 2 minus cot pi over 4 is 1 minus log cosec pi over 6 is, it is reciprocal of sine, right? So it is just 2. Sine value is 1 over 2. So cosec is 2 minus cot pi over 6 will be root 3. Hope it is clear. So applying the log property, we get log root 2 minus 1 divided by 2 minus root 3, 8, right? Have a look at question. We see here numerator is linear and denominator is quadratic, right? Remember guys, while doing integration we had done that if numerator is linear and denominator is quadratic, we suppose the numerator as a times derivative of denominator, right, plus b. A and b are the constants we will have to find. Okay, so that's what we are doing. I'm supposing 2x plus 3 as a multiplied by derivative of denominator, which is 10x, right, and plus b. Good. Then we compare the x coefficient both sides. We get 2 is equal to 10a. A equal to 2 over 10, which is 1 over 5. And b is equal to, now we are comparing the constant part. So b is equal to 3. So a is 1 over 5 and b is 3, right? Okay. And that is how we will write numerator as. Let's have a look. I am right now just integrating it. Okay. For 2x plus 3 I am writing 1 over 4 bracket 10x plus 3. And denominator we write as it is, no issue. And that is why we had supposed, right? Okay. Then guys, we will split this into two parts. See how 1 over 5 is out and 10x over 5x square plus 1 dx, and then the other part will be plus addition of 3 dx over 5x square plus 1. Okay. If you have understood the integration till now, in this first part, while integrating first part, if I suppose the denominator as a, 5x square plus 1 equal to a, so I will actually get 10x dx dA, right? So we actually get 1 over 4 integration of dA over a, it is 1 over 5, sorry. So it is actually 1 over 5 L log a. And what was log a value? A value was 5x square plus 1. Good guys. So this is the integration of the first part. Okay. And then the second part integration, if you observe, we'll have to make x square alone. Okay. Please understand this all we have done before. So I'm just making x square alone by taking 5 common out. So see, I'm doing it. 3 is constant and it is dx over 5 taken out common. So we get x square plus 1 over 5, and that I will write as 1 over root 5 whole square. Correct? And if you remember, it is actually of the form dx over x square plus a square, which is 1 over a tan inverse x over a. So I am using that. This is 3 over 5 and 1 over a. So it is 1 over root 5 tan inverse x over 1 over root 5. So let's simplify that. We actually get 3 root 5 over 5 times tan inverse square root 5 times x. So this is the integration of the second part and this is the integration of the first part. And on that we'll have to apply the limit from 0 to 1. So I'm using upper limit first. Upper limit on both the terms. So be careful guys. 1 over 5 log, upper limit is 1. So I'm getting log x and then plus 3 root 5 over 5 and we get tan inverse square root of 5. That is my upper limit value. Now we'll put the lower limit value. So 0 when we put in to the first part, this entire thing would become log 1 and log 1 we know is 0. So I'm just writing 0 and then plus here when we put in x as 0 we'll get tan inverse 0. Tan inverse 0 is 0. I hope you know this from trigonometry, right? So this is nothing but 0 plus 0, right? So my answer is this form. I hope it is clear to you. 1 over 5 log 6 plus 3 root 5 over 5 times tan inverse root 5 is my answer. Good. As you can see, x times e to the power will apply I late. Okay. So I believe you remember that, but still I'm repeating ILATE. So we have x and e to the power x, which is algebra and exponential function. So x will work as u and e to the power x will work as v. So I'm directly writing down the formula. I hope you remember that formula. Integration of u v dx equal to u integration of v dx minus integration of du over dx integration of v dx and whole dx. So it is x times e to the power x dx minus du over dx, and u is x, so derivative of x is 1, v dx, and v is e to the power x, derivative is e to the power x dx. So it is x to the power x minus e to the power x. So we have done the first part. Now here only I am doing the integration of sine pi x over 4. So guys, sine integration is minus cos pi x over 4 divided by, we always divide by the x coefficient, right, which is pi over 4 in integration here, right? So this is what we have done the integration, and then we'll apply the limits from 0 to 1. So first we apply upper limit. So see, 1 times e minus e minus cos pi over 4 is what? 1 over root 2. So let me bring 4 over pi first, and cos pi over 4 value is 1 over root 2. So that is, we have done the upper limit plugging in. minus the lower limit value we'll plug in now. So 0 when I plug into the first part is 0 minus e to the power 0 would be 1 minus 4 over pi, and cos 0 value is 1, right? So basically we get e minus 4 over pi plus 1 plus 4 over pi. Okay, e and minus e finish. So we are left with this result. You can write it nicely as 1 plus 4 over pi taken out common. So that is my final result, guys, for the integration. Okay, thank you.